I want to make a high-level video here talking about sCrypt and incorporating it into Babbage apps and what that really means for the future of Bitcoin and MetaNet technologies, owning user identity, protecting privacy, and ensuring that people have the rights to access and control their digital assets across any number of different applications they might want to use. So a few days ago, I tweeted out a little thing about how people can actually access their sCrypt contracts within Babbage applications, and how they can actually use all of the sCrypt features now, integrating with user-held keys for digital signatures using like op_checksig inside of an sCrypt contract, but in a way that is permissioned by the user through the MetaNet client. So that's basically a high-level description. And what that enables is all of the sCrypt contracts that have been written that use things like op_checksig, or that use things like in Bitcoin, like the signatures that you can have over the data in your contracts. All of that is now compatible through this piece of code here that I have linked in my tweet with the Babbage architecture, the Babage MetaNet Client, and the permissions that users have within this context. So what that really means is in Babbage, we have this idea of baskets. So users have this MetaNet client that runs on their device, and now app developers can write sCrypt contracts. And if you understand about sCrypt contracts, you understand about like UTXOs, or unspent transaction outputs in Bitcoin. And those outputs are basically contract instances of sCrypt contracts that set up the rules under which people can engage with a particular system or token or agreement that has been reached about how a particular set of events or processes is to go forward. That's really what a digital contract, a smart contract in Bitcoin is. It's like a set of constraints under which something can go forward. It's like, well, we agree that maybe we're going to flip a coin, and then we agree that if I win, then I get the money, and if you win, then you get the money, and that's a contract. That's a very basic one. So we have this idea of a UTXO, an unspent transaction output in Bitcoin. And in Bitcoin, there's these transactions on a blockchain, and then these transactions have outputs, and these outputs can contain the instance of a contract which stipulates all of the rules and the conditions and the constraints under which this type of agreement can be made, and then how it can go forth from there. Who gets to unlock the contract, who gets to get paid out, and under what conditions. So people use sCrypt as a programming language to define the rules for these contracts, and people like Xiaowei, the creator of sCrypt, has written, among many other people, a significant amount of different example contracts using sCrypt for things like zero-knowledge proofs, catastrophe bonds, which are a type of insurance against catastrophic events, and even apparently, I hear, which we'll see if it comes to pass, but like an order book or something, a limit order on chain, or something like that. Ordinals, swaps, BSV20 tokens, all manner of those kinds of things. Hodlocker, locking up your coins in BSV. If you know what that is, then that's fine. If not, then that's also fine. But anyways, the point is, there's a lot of these contracts. And this tweet that I made basically says, we got checksig. We got all these contracts that use this signature checking to be integrated into a system that now is combined with the Babbage architecture. So the Babbage architecture is this MetaNet client. You can, everyday people can just download this MetaNet client on their computer, and then they can run it, and then they can actually use apps that were created by developers, and now those apps can incorporate the wide variety of sCrypt contracts that have been written already without further modification. So that's a significance. Now, I guess I'll provide a little bit more detail here because I touched on it a little bit earlier, which is baskets. So in Babbage, we have these baskets, and these baskets can contain particular UTXOs or contract instances. And those instances obviously contain all those rules that I talked about earlier, when you write a smart contract. So in the Babbage architecture, these baskets that contain these contracts are actually cross-app. So what that means is you have a particular basket ID. Maybe I have a contract, maybe I have a basket that contains, all of the contracts I have with locking up my coins or something on HODLocker or something. And that can be in a particular basket with a particular name, except now, because it's a Babbage wallet with the identity built in and whatnot, any app with user permission can actually reach into that basket and with the user's permission interact with and potentially spend those UTXOs, allowing for many different apps, all authorized by the user, to plug into that user's digital assets. So at a high level, what this means is that users are the ones that have these contracts, and these contracts are stored in baskets, and then an app gets to, any app from any developer can now plug into the contracts that a particular user might happen to have at a particular time, and that app could facilitate the updating, the spending, the utilization of those Bitcoin outputs, those UTXOs, those smart contracts across different apps. And now the user is put in control of their digital contracts. They are put in control because they get to choose which app gets to update things on their behalf. They have that power now. And that's what I wanted to convey here. It's really useful because in this context, now one app can specialize in maybe creating this kind of contract, but someone else could come along and maybe that app goes away eventually. Well, some other app can come along, and as long as people still have their Babbage, wallet, their MetaNet client, and that runs on your own device, and is resilient to these types of failures, at least in its full implementation. It might not be like today, but it's certainly getting there. The point is, it runs on your device, and then any other app on your device, even after the original people had their website get shut down and it's completely gone, someone else can come along, someone else can plug into that same data because it's user-held data across the different apps, and they can actually allow you to continue engaging in the in the contractual process that you've set up from the first app. So maybe you had some coins and you locked them 5 years ago. Well, if the app that you used 5 years ago no longer exists, someone else can come along, and someone else, with your permission, of course, can plug back in 5 years later and can let you access those coins, because that's what it means to have user-held coins and user-held contracts. So that's working now. I'll leave a link in the description of this video to the tweet where I sent out, in that tweet contains some code. It contains a link to GitHub where you can actually look at a contract which incorporates key management within the, and using opchecksig to actually create a signature for a Bitcoin transaction that redeems a smart contract, in sCrypt. And so that's been demonstrated. This is a very early stage system, but it has now been demonstrated, and people are going to take this and they're going to be able to run with it, and they're going to be able to make some really cool things. If you understand this code as a developer, and if you also go on the Project Babbage website, and you also understand the ToDo List app tutorial, if you actually go through that tutorial, and if you also understand this, you will be able to plug. By the end of that, you will have the knowledge necessary. you'll have the experience using the Babbage SDK, and you'll have the knowledge necessary to actually plug together these systems and use any sCrypt contract you want inside of an app that uses the Babbage identity system, and you can actually create valuable things with that. So for those of you, for the few of you out there in this world who are actually watching this and who actually know what we're talking about to a level where you might want to go build something, now you can actually plug these pieces together. Now it is possible to connect these dots and actually create applications. And, like I said, it's early. This is stuff that we're just now starting to plug together and make this stuff happen. But I wanted to make this video just at a high level here to describe some of these concepts at a high level and to encourage you, if you are a developer, I don't know, join our Slack or something and let's chat about this, because there's some really cool use cases that we can start to build. Now that we have the possibility to incorporate any number of these sCrypt contracts that Xiaowei has talked about on Medium for the past 3 to 5 years, now we can build it with a system, a user-friendly wallet that allows cross-app compatibility, and that is the infrastructure that Bitcoin has been missing for a very long time, and it's finally here. So with that, I won't waste any more of your time. I hope that you spend some time to understand some of these things. I'm going to leave a link to that tweet in the description, and I'm going to leave a link to the ToDo List tutorial as well in the description. And if you're smart and if you're a developer, I would love to see you go through both of those pieces of code and put those two things together, and then you'll understand how to create some really cool things on top of Bitcoin, and you will be among the first. So with that, thank you for watching. I hope this has been useful. I'm happy to hear any feedback. Please join our Slack group and yell at me about how terrible my system is, and we will try to make it better. With that, I want to thank all of the people on my team, on the sCrypt team, across all of Bitcoin SV, who has made this reality possible finally. All the people working on SPV, big shout out to Degan and to the people in the VA that have pushed so hard to make SPV work, because that's fundamental and necessary. And with that, guys, let's go build the future. Over and out.